Hi, everyone. Welcome to another Common Lisp study group. I'm your host, Ron Baden with Atlanta Functional Programming. My apologies for starting a little later than our scheduled time at 7:45. I was having some technical difficulties getting the live streaming, but that seemed to have been resolved. Today, we're going to be discussing and continuing our discussion of the 5am library that we were talking about last week. As you may have recalled, 5am is an alternative to the Rove testing library that's already available by Fukamachi. It's actually one of many unit testing libraries that are available for testing in Common Lisp. Rove is one that we've also covered in past. This is part of the CL project generator. Last week, I kind of showed you how to set up your project file. Just a quick uh, show of our project file. I updated the project file to no longer use Rove, but to use 5am. Originally, here you would have seen Rove being part of AFP /test. So if you try loading it, it'll attempt to load AFP /test with Rove and then run Rove run, which will run all the tests in AFP fact. Um, I've also may have shown this to you before already, but if not, just a review. One of the advantages of setting this up, specifically the test op, to actually call 5am run all tests when as part of the as-diff definition is now you can actually just simply run ASD test system colon AFP fact or whatever project your name is, and then this will internally call those tests for you. Um, looks like there is, I may have accidentally introduced a circular dependency. One second here. Hold on. Oh, I'm gonna probably have to restart my Lisp here. Not a big deal. I was doing some experimentation earlier, so apologies for that. Let's go ahead and reload our project again. AFP fact. Another advantage of this as-diff test system thing that I don't think I mentioned before, but it's one of the nice features of it, is as-diff test system automatically loads your AFP /test piece. That test op will check to see if the package is loaded. If the package is not loaded where your tests reside, it will go ahead and load it for you automatically, and then it will go ahead and run the function call, which is the exported symbol that you provided as part of the test op. So if you go and look at this again, we'll actually check to see if AFP /test is loaded. If it's not loaded, it will load it, and then it will do the symbol call. The symbol call is essentially checking to see if there's an external symbol called run all test in the 5am package, and if it does exist, it will go ahead and run it. Otherwise, we'll throw an error. One of the advantages of this is of course, is if you're writing a lot of tests, you could just simply use this as-diff test system feature just to go ahead and, obviously write simple tests here. Like, for example, we can go ahead and write for returns 24. All right. Um, and we can make sure that we define our our uh, our tests here like so, save it, and then when we run as the test system, notice because we've already provided the factorial test suite here, this will automatically get registered. And w- one thing to note about this as if test system feature, it will recompile your test file once these changes are made. Okay, so what we end up actually seeing here, and let me just go ahead and expand this, is as you see that the test file is recompiled and then reloaded, the FASL is reloaded, and then it runs the actual test suite. And again, it automatically registers whatever test suite that we're in, the new tests in that test suite. So in this case, we're in factorial test. When we do this in suite, when we load the feature, it'll go ahead and register for returns 24 as such too as well. Today, we're going to be discussing generators and specification-based testing, a feature that I alluded to last week when we were talking about random testing. And time permitting, I will also introduce the concept of test fixtures. Now, one thing to note about test fixtures uh, before we get started, uh, think of test fixtures when you read the documentation for those who are jumping ahead and looking at some of the examples that are in the documentation, or even examples that may be in our test file here, which is what we're going to be looking at later when we go through test fixtures. That test fixtures are normally what we associate with unit testing, because what a test fixture, at least for those of us who've come from object-oriented languages, say Java or C++, our system under test was the actual object itself, the class that we've defined and its related objects. So if you recall in JUnit or even in CPP unit, the ilk for the XUnit family, you have for each system under test a setup method that goes ahead and resets the state in which you are actually going to be testing on, and then you have individual tests that test different functionality inside that test suite. The test fixture does similarly the same idea. It makes sure that each um, test is defined, the dependencies are set up in such a way so that we can go ahead and hide the context of creating database connections and dependencies associated with actually running the test in a convenient way, so that you could actually reliably run your tests without having too much actual difficulty to check those things in. So this way, the context is provided for you, and you're just concentrating on what really matters, which is your tests for that system under test. But I'm jumping ahead. I'm going to go ahead and first get started on just talking about generators and specification-based testing. Now, those of you who may have come from the Haskell world, or even who may have encountered specification-based testing in your programming language of choice, whether it be Python using, I think it's called Hypothesis, or there is, I think, Py Quick Check, there's CPP Quick Check. There's a lot of Quick Check derivatives that all are inspired by the Haskell Quick Check library. The Haskell Quick Check library is one of the first testing frameworks that implement this particular feature. The idea is pretty simple, which is you have a property that you are attempting to kind of verify, okay? And you want to go ahead and assume that that property exists, and you want to create randomized inputs that, test against that property. All right. So you might, have an idea of, say, um, let's say, you may want to define a property um, in a properties.lisp file somewhere. And let's go ahead and do that, because this is, I'm trying to kind of show you the kind of approach that those libraries are doing. And uh, this is something of just so that if you end up ever using a specification-based testing framework outside in your programming language of choice, not necessarily in Common Lisp, you are just at least aware of it. It might be a good idea to at least understand what this property-based testing is kind of all about. The So let's go ahead and create a quick file here. Let's go ahead and in our source directory, well, we could probably even put it in our test directory. It might be a good idea to put it there. Um, let's go ahead and create a properties.lisp here. Save it. Let's go ahead and then add in our AST file, not that, fact.ast. Oops, sorry, fp fact.ast. In here, let's go ahead and add this file here, file properties. might be a useful. Actually, I take that back. We need to put this in the right order. So because that file is actually has to be loaded first. Um, Actually, you know what? I think I could do this. Properties, and then in here, I think it say depends on, and this should actually do the trick. So it doesn't matter what order is in, it'll actually go ahead and load it. Let's go ahead and double check this. I think I got this correct here. AFP fact slash this. Loading depends on must be a list. Okay, good. So I'm gonna have to go and specify here a list of files. So create that list. Okay. And quote not found required by the. Okay, so we need to go ahead and just maybe just do this. Okay, that works. All right. So right now, our properties file is empty, so this is not going to really do much of a difference. But we at least have the system definition all set up. So let's go back to our properties, and what this property file is going to do is nothing more than tests. I'm going to go ahead and define this as a properties namespace here, and we're going to go ahead and say we're going to use CL here. And we're going to export our properties as things, as essentially functions that we're going to do. All right. Now, for the first thing is we're going to just check, simple equality. I'm just going to call it simple equality. All right. And what each of these properties are is nothing more than a function. Okay. Now, if you look at Haskell, Haskell's function identity and function, like the way you define those properties are going to have a function signature, has what the input is and what the output is. Usually, a property that's going to be used by quick check is just going to take an input. Then it's going to return a bool. Okay. Here, we're going to assume that the return a Boolean. I don't. I'm not going to go ahead and use the F-type definitions to actually go ahead and add function signatures, but you can certainly do so if that really helps you. These functions are just going to essentially do kind of the same idea. So in here, simple equality is just going to take in, you know, um, uh, it's going to take in our function, okay, and um, it's going to take in our um, random integer, our input one and our input two. Okay, and all this is doing is we can say that this guy is just going to simply do an equality check against input two and fun call fun on input one. All right, that's all this is going to do. All right, this is what our simple property is going to check. It's going to check to make sure that when we call function one with input one, it's going to end up equaling whatever we pass in into input two. All right. This is a very dumb property, but the idea is kind of the same idea that you will see if you go and encounter this kind of idea in say Haskell, where you're passing in an input, and then depending upon the input, it's just going to allow you to set up a property. So in the case of, like, say if you're defining an instance of a functor and you want to go and define verify that that functor actually preserved, say, identity, you would have something like a function called functor identity that takes in the actual functor itself, and you just simply call fmap id on f equals f, and as long as the input equals the the fmapped output is equal to the input, then we're actually kind of good. Okay, so that means you've at least preserved identity for that functor. Right? So you're checking essentially properties. This equality here obviously is incomplete because it's taking into well, it's assuming a couple of things regarding about the function and the inputs that are passing into the function. But I'm just making this for illustrative purposes so that we can actually go through and talk about how to actually use this to test some stuff. Okay. Um, so given that property, let's say we defined in a function a function called add to. Okay, this is a function that I've added that just a simple function to test to make sure that we, whatever function that we create is tested accordingly to a plus two. All right. So now we can go ahead and run our randomized test. Now, you might be wondering why I may not be writing a randomized test for this. That's because, for fact, that's because some of the properties against fact mainly will be easily testable for simple cases. But if you want to compute factorial, we have to actually call factorial, which means we need to have another factorial function to test factorial. So you could see that for this particular function, it'll be a little bit difficult to actually go in and test without creating a subsequent sample size and maybe even data-driven approach to actually go and test it. So that way you could actually pre-compute some of those tests and just make sure that those are actually what is actually computed with that function. So I'm just going to take this simple function just for the time being, just to kind of illustrate the concept of what randomized testing is all about. All right. Um, One second. Uh, um, my apologies for folks. Okay, edit and hide. All right. All right. So given this kind of setup, how are we going to create a randomized um, test? Well, in fiveam, although the documentation says this, at least with the fiveam that's available on Quick Lisp, check to see in the GitHub repository if it's changed. But with the fiveam available on Quick Lisp, we have some predefined generators for you to create. Okay, so what is a generator first, right? A generator is nothing more than a regular function, literally a def fun, uh, that defines a way to create randomized inputs for a given say object. So if you create a function that says generate objects, for example, you could define your specification so that it could create different types of objects like a factory and then return those objects accordingly. Right. So in the case of say gen integer, if we wanted to generate integers, uh, let me first go to main.lisp. Here, you might see something like this if you actually go and look in the code. Um, Gen integer key, it'll take in a max that's defaulted into 1 plus the most positive fixnum, and our function for min, it'll be a min, they'll take 1 minus the most positive, most negative fixnum. Okay, and it'll go ahead and with this definition, it'll go and just go ahead and create a set of random numbers by just simply calling random. All right, on 1 plus the difference between um, max minus the min. All right. So it will look something like this, where you can actually generate different random numbers for it, and you can probably test against this. Now, with this specific generator, all right, and there are many of them. There's at least 3 defined. I think there's a float generator for randomized floats. There is one for strings. There's one for lists. um, Go ahead and I encourage you to go and look into what each of those do, just because of the fact that I couldn't think of a good way of testing these things other than doing kind of a weird function that will just do string concatenation, for example, in the case of lists, in the case of strings, or list concatenation in the case of lists. Uh, but that's simple enough that I'm sure you can all look at it once you get the idea out here. The main thing to recognize, and that fiveam provides you, is something called the for-all macro. All right, and the for-all is actually what is the meat of all this test. Okay, it will allow you to generate a test for testing, the simple functions here. Okay. So one idea is you could actually go ahead and define a test. Let's call it um, test add to. Okay, and what we'll do is we'll call for all, and for all, by the way, is actually a macro defined in uh, our testing library in our fiveam library. And this actually generates a series of trials, all right? And it introduces, in order for this to all work, it introduces two new earmuffed variables, global def parameters. One is fiveam num trials is defaulted to 100, and the other one is fiveam max trials, which is defaulted to 10,000. So you might be wondering what the differences is. I'm going to touch base on that in just a minute, but first let's go ahead and just keep in mind of these num trials and max trials, because it's important, because it's related to how many times our tests actually run. Okay, and there is a difference between the two. The But again, I'm jumping quite ahead. Let's go ahead and first write our basic test here. Okay, so we have this test that we're going to be, and a function called add to that we're going to be testing against. And so what we could do is we could first create, say, an integer using fiveam gen integer. And again, this is calling that function as defined, as I put in the comment section there. Okay. So now we can actually go in and call or run a bunch of tests against this. Okay, so you could just run, say, if you really wanted to, although this is completely unnecessary, you could write a simple test as, say, IBM check that you actually got an integer. All right. Which is pretty ridiculous because we already have an integer for associated, but we can actually then test the actual function, which is say um, add to on a is equal to a plus 2. All right, which is one way of actually defining these randomized tests. You don't necessarily need to write the simple equality. Now, if you're coming from the Haskell space, you might end up using, say, um, IBM is, and then all you need to do is just simply call our AFP fact slash test slash properties, and call simple equality on the function add to with the parameters of a, and what we're going to check is a plus 2. All right. Now this looks a little bit more, one second. Did I forget to, oh, right. Um, 1 second, quit, XB, properties.lisp. We defined it, but we forgot to say in package AFP fact test these. Okay. So let's go ahead and, oh, oops, sorry. For, oh, Oops, spelled there. There we go. So we're in here and we're in here. And now we've defined our, we interned it in that package. Actually, it's probably better to do this. Um, uh, Load this correctly, and now we have our package exported with the appropriate definitions. So now we can go back to this and we could run this and we end up getting compiled. And this definition here, you may be wondering why this is. Forall allows you to specify as many tests within the context of Forall and run all of those tests multiple times. Okay, you could define any sort of properties, and you could either define them directly in the test like so, or if you want them reusable, you can actually go ahead and certainly define them in a separate space like I did here, export the function, and then call them. All right, and it will be functionally the same thing. Now, those coming from Haskell, this approach right here is kind of what you ultimately are doing with quick check. You are defining a function that will take in the function and then verify its properties accordingly. Those coming from other tests, they have different approaches to doing specification based testing, but unfortunately, I am unaware of how those are actually defined. So I encourage you to go and look at your language for based test if you so choose not to use fiveam to do your testing, but you want to take a stab at understanding um, specification testing before using fiveam for your testing needs. So now we have this defined. Let's go ahead and run it. Okay. Again, I'm just going to go ahead and use as the test system for this just because I really don't want to find this. You could see here that when we ran it, it ran multiple number of times, as indicated by the periods there. One thing to note about that is the number of each dot represents a trial, okay, and the number of trials actually equals num trials, as I showed you earlier, right? Um, so you might be wondering, well, what's the difference between num trials and max trials? Because you showed us max trials earlier. I was looking at some experimentation. According to the documentation, num trials determines how many times you run the specific body. So all these forms here that represent the body of the test, they are run num trials, all right? But um, the number of actual times you attempt to run the actual body is max trials in the off chance that you have some cases that fail. All right. So if there are some randomized inputs that fail, they will actually go into the fail list. So they have something called for all test failed, and then for all test passed. And max trials is actually used to um, essentially determine how many times did they actually run for all when the body is actually skipped. So when the particular form is actually skipped due to failed guard conditions, so failed conditions, and we'll see that in just a minute on how this is all kind of worked out. But one thing about this is then of course if you're doing this actually makes things a little easier. You could certainly say, oh well, in my CI system I want num trials to be more than um, when I'm running it on my local REPL. So what you could do is before you run anything on your local REPL, you could always set this to be something short, like say 10, and then run at, as the test system, and it will go ahead and do this. It'll only run those 10 times, or and then obviously have different settings for different types of randomized testings here. So one of the advantages of this is of course because generation of the objects are very simple, you can actually think of creating just a simple factory method that will generate random objects for you for a given class that you're trying to test against. And then you could use the for all macro to actually go in and actually generate your test runs and actually get more resilient testing, especially for complicated objects that have nested objects and complicated methods that you've defined for those instance objects. So this will give you a bit more flexibility on that. What Forall does is, as I mentioned, is it is a macro that actually expands into the following. Let's actually take a look at this and dive into this because I thought this was pretty neat. Um, Forall actually expands into this function called perform random testing. Okay, and what it does is it will generate a series of randomized integers first. Okay, because we're calling fiveam gen integer here. All right, but it's not for every trial. So for max trials or for num trials, it will generate a list of all these randomized input, and then it'll call this lambda function that's here called that's defined has the following. We'll take in the test lambda, the predicate that we've defined, which is a series of forms that represent the body, and it will check to see if each of these are actually verifiable. So you can see each form in the body, okay? So like let's say integer p becomes a test that it verifies here, okay? And if it passes, it'll generate a new instance of 5am, sorry, 5am test passed is of type uh, which will go into the list of all tests pass. And it's calling this add result function that is keeping track of all the instances of the test passing and the test failures. All right. And additionally, it will go and check to see if each of them, each predicate gets its own, or test gets its own kind of like separate case that you would actually go in and verify, right? So obviously in this case here, this is a function call to the actual simple equality. For folks who are looking at this one here, I have yet to figure out why it's and wondering why it's a prog n in that if statement there. I have yet to figure that one out. I'm not entirely sure why the macro expansion goes to this prog n to determine the equality condition, because the equality condition will return just true or false there. So I'm unaware of what the reason is in this macro expansion for this prog n. I'm not sure what the best practices is. So let's go in and actually try a test failure just to see what the difference is. Obviously, I'm going to make a test mistake. I'm going to put a mistake in my test on purpose here. So I know what add two does here, but let's say that we want to test add one here, like so. If we run the test case, you will see that in our case here, in our test results, it actually determined that there's out of the 10 or so trials that we're doing, that it attempted a couple of passes in test add two, but after a certain number of trials, the failure rate actually determined whether or not they should um, if the failure rate is above a certain threshold, and I'm not entirely sure where that threshold is defined or how that threshold is determined. I'm assuming it's based on number of trials divided by max trials, or max trials divided by num trials. I'm not entirely sure. Um, but if that percentage is a certain size, it's going to automatically abort the randomized test because it doesn't really care. We it failed enough times that it's significant, so we don't have to actually run it multiple times on randomized inputs, and it'll go ahead and dump the inputs where it kind of failed on. So this allows you to obviously then look at your test results and give you some meaningful information. Uh, Obviously, in our case here, it turns out that it's not our function that's wrong, it's our test that was wrong. And we could go ahead and just correct that here and then simply run this, and we end up getting our test suite here running after the 10 trials. Are there questions about this? Okay, cool. All right, so let's talk about fixtures. So I'll be honest with you, I haven't had a I haven't figured out a good way of actually a good example for test fixtures. So I'm going to kind of walk through one of the tests that I think I found in the list of available um, where is it? List of available. Yeah, hold on. Sorry. My apologies. We need to get this back to Sly mREPL. Okay. And now I can actually change this to test.lisp. And let's see here with fixture. Okay, so this doesn't have with fixture. Where was with fixture defined? Give me just 1 second here. Let's see, maybe it was with test.lisp. With fixture. So this is defined as with fixture here. Let's see what this function is doing. Let's see here. We've defined a test suite by generating it, and then we define test names and then tests. Ftest actually generates okay, so we're gonna have to go in and try this ourselves. All right, looks like I did not find an appropriate one, but we'll see what we can come up with very quickly. Let's see. So for this, let's go ahead and first define, I think the easiest way is to first define a class, all right, that we're going to just use. And we're going to go ahead and define it a good standard person class with name in it, arg, name, arg's name. In it, form is going to be nil, the accessor is going to be name, okay? And let's go ahead and provide age in it, args, age, in it, and then accessor is going to be, let's actually do this, person name, person age, so we don't actually lose sight of what we're dealing with. Of course, you know, since these are going to be generic functions, it'll be nicer to actually use probably, let's go ahead and do this. It's probably easier. And let's go ahead and find this guy. Okay, let's go ahead and then make sure that I actually set this up correctly. Name, age 36, and it'll define it. Oops, right. I have to go and obviously set my package and do AFP fact here, and then I do this. We could see email and initialization arguments. Hold on 1 second. That's the reason. This was an arg. An args. Okay. Okay. we have our object all set up. Okay, so what we're going to do is we're going to define. Obviously, you don't necessarily need to define tests against the accessors because we're not actually generating that code. That code is part of the Lisp implementation. Of course, feel that different Lisp implementations are being that may have some bugs in their implementation of the meta object protocol or the object, and you're just trying to test it, you could certainly do so, but I'd advise against that. One of the nice things that you could certainly do if you're going to go ahead and go that route and you're trying to test construction is to test construction, say for initialize instance, because normally most people who are going to be doing this, they could certainly create an after method here and then provide initial arguments for this. And currently I will not go down this route and kind of show you this just merely because it, it it would require just a little bit more um, talk about initialize instance and being an kind of an after method that you then specify some information about it. So, but right now, for our example, for person, there isn't really much that we need to do initialize instance after anyway, but we could certainly do that at some point for another example for a more thorough test. But here in with a person, you can actually go in and at least define a generic method, say increment age or something like that, or get older, right? Where you define, we just take the person, okay, and internally, um, you may not want this as an accessor. You may end up actually wanting this as a reader because then they can call instead of making an accessor where they can actually set the age to be anything. When they initialize it, it'll be initialized a certain way, and unless they call this get older function, it will not actually allow you to modify the object. Okay, so in this case, we go ahead and do this, and then if we define, say, this now, if we try and attempt to take age person and then set it to like 38, go ahead and complain because there isn't actually an applicable method for that specific thing anymore, right? It's been redefined. Um, so now we can actually go ahead and do the following, and we can actually do I think it's an incaf that actually does the automatic set app for you. You can certainly do one plus if you wanted to, but this is actually a much easier way of doing it. You could just go ahead and say, oh wait, I don't want to do slot value. A better way of actually is using with slots instead. So we could do this. Sorry, control and say with slots. And we could say age from person, and just to make things a little bit even more, let's say that this is a person using the kind of small talk style syntax there a little bit. We could just go ahead and do an increment age, and this what's the word error? Unsupported option. Did I accidentally do? Let's see. It looks like I can't do that. Okay. Well then, let's do it this way. Multiple ways of skinning a cat. Uh, let's actually, instead of calling this, go ahead and do obj. Oh, right. I'm using def generic and not def method. Okay. So this here we're defining, we need to actually go ahead and find part of the def generic, the actual documentation string. Let's go ahead and, find the documentation, increase person's age. Okay, and now we can def method that folder where we specialize this to be a person instance, and now we can actually do slots age obj and def age, and now we have it. So now, in the case of what we did earlier, if we now go in and say get older star, go ahead and do that, and if we go and check our age on the earlier person, it's going to go ahead and be incremented accordingly. Okay. And if we go and look at the last person, and then look at his ages, you can see that it's been incremented. All right. So we have this basic kind of like structure for this, but obviously you don't want to just test this manually with the REPL. You want to have a test that will systematically go ahead and test this every time you go and write a unit thing. So you'd want to write a unit test against this. But you want to go ahead and test multiple methods according to this, all right? So one way of doing this is creating a test context, all right? And that test context is what we're calling a fixture inside, you know, um, our inside fiveam. Now, this is going to be the first time that I'm actually going to be playing around with fixtures in this context. So I'm going to make a couple of mistakes while I'm going along the way, but I'll try to tell you where my confusion arises, or where I think there's some nuances that you have to pay attention for. But this is going to be the basic idea. Um, let's see, what else can we add here? Let's go ahead and add one more thing here to make it a little easier. Occupation init arg, and let's say occupation, and then let's make this guy reader too as well. Actually, we don't need to make this a reader. We will make this an accessor. And here we go. Let's call this reader, and let's make this a little bit more complete. Let's make this a first name and a last name. So this might be useful for, say, if you are, you might have a maiden name, like if in some females and they change their last name to being something, then when they get married, or males will do that so as well sometimes, depending upon whether you do it or not. So we'll go ahead and do this and say that this is Peter last name, and then we have our full one I may have accidentally forgotten, occupation. All right. Okay, so now we have our redefinition here. So we can't use the previous test just thing. I'm going to go ahead and add a couple of methods that I think are pretty useful. Mainly, say, print object, I think is very useful. Go ahead, and I think with print object, I need to take in a stream. And what I'll do is here, format stream %s %s d %s tilde percent. Oh, not percent. That's thinking different language here. It's tilde s and tilde d. All right, now we have it. Then we'll go ahead and call this with slots First name, last name, age and occupation for the OBJ. All right. Now have this defined. Oh, wait, I forgot to actually provide. All right, so now we have this. Let's go ahead and check this guy out here just to make sure. And let's go ahead and actually, oh, sorry, back. Let's go to our test case and then write, oops, accidentally did that. Yes. And let's go ahead and add one more method here. By the way, I know I'm defining a def generic and def method, but in this case, I'm just doing a def method. Def methods will automatically generate a def generic if it's necessary. So I know that this is probably not kosher, but we'll go ahead and do it. Change last name is probably what I should do. Okay, let me just go ahead and say changes a person's last name. All right. Okay, and let's go ahead and do the def method. Let's follow proper protocol here, right? So let's define this, and well, let's do this with slots. Actually, I forgot the name. Redefining this and new name, and I know it should be really new last name. Okay, and then we do last name on OBJ. And we'll do setf last name with new last name. Okay. Okay. So we have a couple of methods here. Obviously, there can be more, but this is probably good enough for the sake of our example. Now what we'll do is we're going to go into, oops, we'll go into main.lisp test. We're going to go ahead and define a fixture. Okay. Test def fixture. This is going to provide a name of our fixture. Let's call it test fixture. All right, I know that's it lacks a couple of things. And what this guy does is this is a macro, all right, and it'll take in our object. So let's say that we've defined a parameter, test obj, make instance, and all right, I have to go in and export. So let's go ahead and export person, export get older, and export change last name. Okay. Let's reload this guy into our REPL. So now everything is nicely packed into our package. And let's go back to this and we'll create our person instance here. So create it. First name, John. Obviously, last name is going to be famously Doe. And, you know, his age is going to be 35. Okay. And his occupation is Lisp programmer, since we are in, of course, the greatest programming language ever. I'm not trying to start a flame war, folks. I'm just kidding. I'm just kidding. Since it's a common Lisp study group, that we're having some fun. All right, we're having some fun. All right, you know. So now, my understanding is with test fixture is we provide the objects that we're defining, and then we specify the forms, the body that this fixture is going to be on. Essentially, let me just make sure it says true. Let's say equals well, EQ in this case. I think is test obj. test object. Let's see what happens here. Do a macro expansion, then we are actually all good. If we can't, we have a problem. Sure, test cons test is equal. It looks like we have takeoff. Let's see if this actually runs now. And it did not actually register any sort of fixture or bodies. I am wondering why. Let's see. Uh, I think I may have used this wrong. The body has to be just setting some stuff. Yes. Okay. Let me see if so it has a list of them. All right. Let's go ahead and do this. This is not the body is actually the actual list of all stuff that we're going to be defining. So let's go ahead and add this if that's the case here. And args, I'm not entirely sure what the args is for, but obj is, let's see what happens here. Oops. I macro expand 1. Okay, so now we have test fixture connected with it has a list of names, but it doesn't actually tell me. Okay, so now let's see what happens when we use test fixture then. With fiveam with fixture test fixture. Okay. So I need to specify anything here. Let me see. Equals 1, 1. Just a simple test, folks. Just trying to see what the macro expansion is of this. We expand this, we end up getting the following. Okay, so proghen equals 1, 1, lambda fun call, test object has so these arguments are being passed into the function call of the, but it does not actually tell me why. Hold on, this is generating, inserts the body into the fixture name. Inserts the body into the fixture name. What does that mean? Get fixture. Okay. So This is kind of interesting. So this fixture that we've defined here creates essentially um, this first macro creates essentially a context. But if I'm understanding the context is it separates the arguments that are going to be passed into the body itself from the body. All right. And what it then does is it generates a function call with texture, with the test fixture, all right? And what it does is specifically actually is it injects the body that we provided into the actual um okay. So let's see how this works. This looks kind of weird, but let's see if this all kind of like at least gels correctly the way we're looking at it. Let's see what happens. Um, error compiled source. Oh, test object is defined but never used. Let's see here. Let me see if this actually works the way I expect it to. Okay, so we know that we have this test object here. And let's say that we define it so that, let's make sure age test obj is 35. All right, we know that it is 35 here. All right, so if I do that, invalid arguments 0. Let's see here. Test is unbound. Let's see what, hold on. So this is okay. With test argument fixture's name, I don't know what the test what the arguments should be, but let's see what it looks like. We need to pass in some sort of arguments. Is weird because let's see what happens here. Macro expand 1. It generates test object lambda. Ah, now I see what the problem is. Okay, so we're actually, this is not generating what I expected to. It's injecting the body of the function call into the lambda instead of the other way around. I would have expected that to be the test context. Let's see here now. So how do we actually do what this is actually generating? So we need to create dummy connections, simulate an HTTP request. Fixtures conveniently hide this context. The test focus on testing. Okay. Macro let body prog test age object. Okay. If I do this, this should totally be wrong. Test object is never used. And this unstyle warning. Test object is defined but never used. So let's see this. See what happens here. Invalid number of arguments because, okay. There we go. So now this is all kosher. So we defined the test fixture. We're using the test fixture, but it looks like it's not actually using it the way I expected to. Because macro expanded, this is going to do something that I don't think is right. I'm going to create a macro let, then creates a no argument construction that simply injects our test fixture context into the fixture name. But it doesn't actually inserts body into the fixture name. So let's see, insert construction bind, grab the L arguments, grab the body. Okay, let me see what def fixture does here. Okay, this will not work the way I expect it to. If I do this and I try to run test system, it's going to complain. 7. Oh, right. So, okay, now we have this, but it doesn't actually, it only has, okay, so let's go ahead and do this. fiveam, let me see if I can do this. Test, fixture test. Does not take in any arguments, and all it does is it's gonna say equals, and let's see what um okay, so it looks like I'm gonna have to, let's see here, test object, even though test object doesn't exist anymore. Let's see what happens here. Let me see what happens here though. If I do test object here and specify this. See, the test object's unbound, right? Let's go back to this test fixture that we just created earlier. Try this again. I think it is requiring me to first figure out the test fixture here. So in order for me to do this, I have to do fixtures very much. It's supposed to be simple templating. So the idea is it takes the name of the fixture, say in this case test fixture, and then it creates a cons of the arguments passed into the fixture and the body of it, and then it returns the name of it. Okay, the symbol. So in this case, we're saying test object is the arguments, and then supposed to create dummy connections here. Oh, I think I have it. So the fixture defines the test that we're actually going to create. And then the with fixture actually takes in our context and then calls those tests accordingly. So if we expect a test DB to be created or a test object to be created, we need to do it the other way. So we need to first define our fixture first, which I think is our with def fixture. So I might be doing this wrong. So let's do this one more time. And let's say that with our def fixture, we have tests associated with it equals age test obj 35. Okay, is equal first name obj. Okay, and obviously here we're going to have to do the string equal. Then is string equal last name test obj. And finally is string equal occupation test obj. Hold on one second. Oops. So that way, and programmer. Okay, there we go. There we go. So this should compile. Now we need to inject the body. And if we go into here, we should see a list of stuff. Let's go ahead and check. Slash macro expand all. One compiles it into the following list. Okay, so now let's go ahead and say with fiveam with fixture test fixture arguments is going to be the arguments that we're going to be creating. So in this case, make instance person, first name, John, last name, so age 35, occupation, programmer. And I don't believe we need to specify anything with the body. Let's see what happens here if I do that. And do slide macro expand one. See what happens there. Lambda function call test object make instance. This is, I think, what I needed. Anyway. Okay. So let's see if this actually runs. Test main age is undefined. Okay, so I think we're making progress here. We need to actually go and export in our source the accessors that we created. So first name, last name, age, and occupation. Let's go ahead and make things easier on us. Let's go ahead and restart our Lisp because we've created a bunch of Lisp. Okay. I don't know, AFP fact, this should not cause any problems. Good. Let's do test system AFP fact. And we now have current test is unbound. So let's check where that is occurring. I'm sure it's related to our test fixture. So let's go back to this. Let's comment the region. Okay. We run, we have 6 tests. Let's go ahead and now uncomment this guy. Okay. And let us do this. And you can see current test is unbound. All right, so fun call. So this is expanding into what I expected to, but it doesn't look like it's doing what I expected to. So I'm wondering what is going on here. Let's see. Do slime macro expand again. Do. Ah, okay. So it didn't actually define a test for us here. Let's see here. Let me go ahead and do that. Okay, that's not a big deal. Let's go ahead and define here. Okay, define fiveam test. Say test person. Okay, and what I'm going to do is I'm going to go ahead and slurp the rest of stuff. We define this, so we now have a test. We define this, so we are saying test object is actually not being used here for some reason. And let's see if I could do fun call test person. And hold on, I can actually specify the arguments here. Test name and body. I don't think I could do that. And if I do this, we'll see this again. This, I should have a failure somewhere, undefined variable. Yes. Test factorial tests in this test person check is actually incorrect. So let's go ahead and fix that. To fix it, I'm going to have to figure out how this test person or test variable thing is unbound. Mm, do this, this, this. fiveam current test bound. Okay, it looks like there is still a budding question that I'm going to have to go and play around with regarding test fixtures, because the macro is not doing what I expect it to do. But the idea is kind of the same thing. I think it's def fixture or width fixture in general. It'll allow you to go and inject into this. We'll come up with a more decent example for this. I think that would actually make it more prudent, but unfortunately, there is a bug in this that there's something that I'm missing in terms of the ordering in which how I define the test fixture and the context in order for us to actually go and use them. Fixtures is supposed to hold, technically, my understanding is a fixture is supposed to literally hold the instances of stuff that you want to go and define. So in here, it should be something like this, where I do this, and then I do first name John, and then last name Joe, age 5, and then occupation Lisp programmer. Okay, and although this is here, this should now take with fixture, test fixture, and our test object, because now we've actually acquired it. It's supposed to essentially expand this into allowing me to use it within, say, defining a test person. And then I can actually go and say equals age test obj. You can see that test object is being set to unbound, and makes sense when you actually go and look at the slime macro expansion why this is complaining, because although this is right, because the prog n is defining a test here and it's trying to inject into it. Here the fun call is actually not actually the fun call is actually taking in the is expecting the test object to be passed in as a parameter, and that's what's throwing me off a little bit there. So I have to go and look into see how this all kind of interacts a little bit more detail, and I'll provide a follow-up later this week on this, just so that we can close this one out. And next week, we'll actually try and leverage this to actually do more database-based testing, which is commonly where test fixtures like this and even writing web services is commonly used, so that we could actually simulate some of this stuff. So tune in next week for more discussion on just testing in general, and particularly fixture-based testing using fiveam. I will go ahead and once I get this kind of stuff resolved, check in this code into our source repository and do a follow-up presentation related to this. Are there any questions? All right. So if there aren't any questions, I will see you guys next week. Thanks.